today's video, we shall be looking at how to solve indefinite integral. Imagine you're given a question like this. The integral of 0 to 1, the integral of x squared plus 1 dx. To solve this question, we'll first of all integrate this expression, and then we apply the range, which is 0 to 1. To solve this, let's start with integration. To integrate this expression, we have x squared. Integrating x squared will give me x power 3 divided by 3, right? And integrating 1 will be x. Then we write the range 0 and 1. So what this signifies is that wherever we see x, we have to substitute 1, then subtract it with. Wherever you see x, we have to substitute this 0 as well. Okay, and let's simplify further. And I have this to be 1 power 3 divided by 3 plus 1 minus 0 divided by 3 plus 0. Since everything here is 0, then we have to ignore this part and simplify this further. So to simplify this further, this is same thing as having 1 divided by 3 plus 1, and this is equal to 3 divided by 3 here. Then you have 1 plus 3. This is equal to 4 divided by 3, and that's the final answer. Consider this question too. If you have the integral of 1 divided by root x from 0 to 4. To solve this, let's integrate this. And for us to integrate this, we have to rewrite this expression in different form. This is same thing as is 0, 4, then x raised to power negative half. So, and with this, we can integrate it easily. And to integrate this, we'll be having x power half divided by half, and this is equal to 2x power half, and it's still the same thing as, forgot the 0 and 4 is 0 and 4, and this is same thing as 2 the square root of x. So at this point we can easily substitute. So this is same thing as 2 the square root of 4 minus 2 the square root of 0, but this is equal to 0. Then 2 the square root of 4 will give us 2, then, and this 2 times 2 will be equal to 4, and this is the answer. Consider this example. The integral of cos squared theta minus 1 divided by sine theta from 0 to pi. Sine squared theta from 0 to pi. To solve this, we have to first of all integrate. Before we integrate, we should have it in mind that there is a trig function where you have the sine square theta plus cos square theta is equal to 1. So, but we can say that sine square theta, this should be the theta here, there should be the theta here. So, and we can say that sine square theta is equal to 1 minus cos square theta. So in this case, we can use this expression and substitute back in the equation. So writing back our equation, we have this should be like the integral of sine squared theta divided by sine squared theta d theta, and sine squared theta can cancel sine squared theta, and we will have 0 to pi d theta, and integration of this will be theta from 0 to pi. So, and this will be equal to pi minus 0, which is same thing as pi, and this is the final answer. Consider this example. The integral of x power 4 plus x squared plus 1 dx. This is from minus 1 to 1. First of all, we have to integrate this expression, and to integrate this, we have x power 4, x power 5 divided by 5 plus x power 3 divided by 3, and the integral of this will be x within the range of minus 1 and 1. So at this point, we have to substitute x, substitute 1 in place of x, and this is equal to 1 power 5 divided by 5 plus 1 power 3 divided by 3 plus 1 minus negative 1 power 5 divided by 5 plus negative 1 power 3 divided by 3, then minus 1. So let's simplify further. This same thing as 1 power 5 is same thing as 1. Then we have 1 divided by 5 plus 1 divided by 3 plus 1. And yeah, the negative can cancel, then this should be plus into 1 divided by 5 plus 1 divided by 3 plus 1. So since the expression here and here, they are the same, you can just put it as 2 into 1 divided by 5 plus 1 divided by 3 plus 1. Okay, let's simplify further. Then I have 5 this should be 1 plus, no, I have 15, sorry, this should be 1, this should be 3 rather, and here is 5 plus 15, and three plus 5 is 8, then 8 plus 15, 23, and this is equal to 2 into 23 divided by 15, and that should be 2 multiplied by 23 would be 46 divided by 15, and this is the final answer. Thank you for watching this video. If you have any question, feel free to email us at nesalifacademy@gmail.com, and kindly subscribe to this channel for more updates.